All right, guys. We had gotten to number 5, A and B. So I'm picking up with letter C for you. And let me kind of erase some of this so you can see. Okay, I'm up to letter C, which is finding the points of inflection. Okay, so what I needed was the second derivative. So here's the first derivative. Now I'm going to do the second derivative, which is 24x squared minus 8. I'll set it equal to 0 and factor it completely. You can, to find the possible points of inflection, you set the second derivative equal to 0. So I set 3x squared minus 1 equal to 0. So I add 1, divide by 3, and x is plus or minus the square root of 1/3. So I'll use a number line here. And then you need to do a test point here. If I plug in, let's say 2, that's positive. If I plug in 0, it's negative. If I plug in, say, -2, that's positive. So the points of inflection are going to occur at negative radical 1/3 and positive radical 1/3. And in order to find the y values, you have to go back to y equals 2x to the 4th minus 4x squared plus 1, and you're going to plug it in. The nice thing is it's going to give you the same output. If you really jump over here, the square root of 1/3 squared is 1/3. So then if I take it to the 4th, that's the 1/9 power. So that's 2/9 minus 4/3 plus 1. So let's build a common denominator. Oops, sorry. The common denominator is 9. So I got negative 1/9. So it'll be the same for both then. Sorry about that cloudy mess there. So those are your points of inflection. All right, that's number 5. Then let's look at number 6 together. Number 6, let me go on to the next screen. Number 6 says, let f of x equal the integral from 0 to x of cosine t over 2 plus 3/2 dt. And it's on the closed interval from 0 to 4 pi. Letter A says approximate f of 2 pi using 4 inscribed rectangles. So the first thing I need to do is find the width of the rectangle. So we do b minus a over the number of rectangles. So this is going to be 2 pi minus 0 over 4. 2 pi over 4 is pi over 2. So I'm going to make 4 tick marks to 2 pi. And if you plug in the function, okay, because remember, f prime of x is going to equal little f of x. So I can plot this one from 0, we'll start off with 0 to 2 pi. So if I plug in 0 into this function here, the cosine of 0 is 0. I'm sorry, the cosine of 0 is 1. 1 plus 1.5 is 2.5. Okay, so I'm just, if you need me to, let me make a table here, okay? So if I plug in 0, that's 2.5. If I plug in pi over 2, that's the cosine of pi over 2 over 2 plus 3 halves. Well, that's pi over 4, which is radical 2 over 2 plus 3 halves. Okay, that's a plus there. So radical 2 is around 1.4. Yeah, and this one, the answer is a decimal, and I know this part said no calculator, but I'm thinking we have to do a calculator here in order to do that, because otherwise, you know, I don't know how else we would do it. If I do pi, that's the cosine of pi over 2 plus 3 halves, which would be 3 halves, because cosine pi over 2 is 0. And then I've got 3 pi over 2 and 2 pi. So if I do the 2 pi divided by 2, that's the cosine of pi is -1, so that one's 1/2. So let's figure out the cosine. 3 pi over 2 over 2 is 3 pi over 4, which that's negative radical 2 over 2 plus 3 halves. Alright, so let's just do our best to estimate this. So this one's about, what, like 4.4 over 2, which is around 2, so it's dipping down a little bit. At pi, I'm at 1.5. At 3 pi over 2, negative 1.4 plus 3 is about 1.6, so that's about 0.8, so it's still coming down. And at 2, it's here, okay? So if I'm going to do 4 inscribed rectangles, that means they're inside the curve. So notice it almost turns out to be right side Riemann sums. So the width is pi over 2. And then you're really doing f of pi over 2 plus f of pi plus f of 3 pi over 2 plus f of 2 pi. So let me just go over it one more time. A rectangle, the area of a rectangle is length times width. Okay, the width for every rectangle is pi over 2, and the height is the right side of the interval. Okay, what I would suggest you do in y1, enter the cosine of x over 2 plus 1.5, and then do this on your calculator, and letter A's correct answer was 7.854. Okay? Letter B says find f prime of 2 pi. And what we wrote on the other side, if f of x is the integral, capital F of x, the integral from 0 to x of cosine t over 2 plus 3 halves dt, then we know by the fundamental theorem of calculus that this equals f of x, and in this case, that's the cosine of x over 2 plus 3 halves, okay? So, if I want f prime of 2 pi, this will be f of 2 pi. So that's the cosine of 2 pi over 2 plus 3 halves. That's the cosine of pi. And we know the cosine of pi is negative 1. So the answer for letter B was 1/2. All right, then the last part, letter C, was to find the average value. And we have a formula for average value that you guys are supposed to remember. It's 1 over b minus a, the integral from a to b of your f of t dt. So, if I want to find the average value of f prime of x on the interval from 0 to 4 pi, you're going to take 1 over 4 pi minus 0, the integral from 0 to 4 pi of the cosine of t over 2 plus 3 halves dt. So now you are doing the integral here. So that's going to give me, when I can integrate this, okay? And you do need to do that u is t over 2, so du is 1/2 dt. So 2 du equals dt. So let me move this down a little bit for you. So this is going to give me 1 over 4 pi, and now I'm going to integrate it. This is going to be the sine of u, but the u is t over 2, and you'd multiply by 2, plus 3 halves t, and I'm evaluating from 0 to 4 pi. So this is 1 over 4 pi. I'm going to do 2 times the sine of 4 pi over 2 plus 3 over 2 times 4 pi minus, this is 2 sine 0 plus 0. The nice thing is that second half just cancels to 0, and I get 2 sine 2 pi plus, now 2 goes into 4 twice, so that's 6 pi. All the other stuff was a 0, okay? Uh-oh, I don't know what I just did. Oh, you guys. Oh, thank goodness. Okay, nope, that was the wrong thing. Okay, I do not know what I just did, but let me just get that last screen back up, okay? Sorry. So this was 2 sine 2 pi plus, and we had 3 halves times the 4 pi, okay? Well, this is 0. And so 1 over 4 pi times 6 pi, the pi's cancel, and the answer is 3 halves. So I hope this helped.